Good day, my name is Jason Theodore Soehardi from Asia Pacific University. The project that I intend to present is regarding an app to design SMPS transformer. The proposed app will be very beneficial for all parties involved. The app is run to have a transformer design with a good amount of efficiency, regardless of how small or big the input parameters are. From input parameters, the app will process the best design with core type that is suitable with the values, and it provides best winding construction. It is hoped that the project can be very useful in society, with several considerations for the project to be sustainable for society. The transformer design should help every user to get the benefit of having a great efficiency transformer. The considerations are classified in two parts. The first consideration is social impact. The goal of creating transformer design software is to be user-friendly software. The word of user-friendly means that the software should be attractive and easy to be operated by user. From the beginning of software, user will be guided step by step of how to design transformer. User will be guided from the first step of how to select the SMPS topology and how to put the input parameters into the software. The next consideration is economic consideration. The software to design transformer takes no cost and everyone can try to use it for free. With no payment in order to access the software, people can save their money and it will benefit the economic, compared when they have to pay some money to get software-based transformer design. Now, let's take a look on the software. The software improves some of the weaknesses found in existing apps. Based on researches, some of the existing apps have either complexity in designing SMPS transformer or incomplete parameter analysis, core type options, and winding construction. One of those aspects are usually missing from the existing apps. So, in this project, the weaknesses will be overcome. With these apps, the comprehensive steps of designing transformer are served with the first page of input parameters. As you can see, it consists of input voltage, output current, and switching frequency. From inputs, the system will process which core type is suitable to provide best amount of efficiency. From the simulation, when I took the example, the first one, when I took the V in for 100 volt, V out for 24 volt, I out for 5 ampere, and frequency for 100 kilohertz, using forward converter topology. From input parameters, we can see the results on the next page. As you can see, the wire specification of which AWG type is needed and core geometry to find core type are determined. Then, from this data specifications, we can go to the next page, which data transferred from these outputs. Okay, this is the next page. The core type options, based on the input parameters we put, there are EE, EPC, or PC core type. In this simulation, I will choose EPC type, and from the core type chosen, we can see what's happening inside the software program. Now, here's the results of the final construction winding. It can be seen from the desired inputs. The simulation will directly show the winding construction from primary winding to secondary winding. The core type options have more than 100 types available, adjusted from its core geometry, which can be obtained from output power. It gives many options to user and the system is very comfortable to use, based on the appearance and simplicity. Simplicity is one of the main advantages of this project. In the software, the instructions are easy to understand, and user can do their desire easily from putting input parameters to having output parameters. Even for a person who has never learned about transformer at all, the software simplicity and all of the instructions will enable a user to learn new experience about designing transformer in order to understand more about transformer design. There are many core types that can be used for SMPS transformer design, as well as topologies. From input parameters, there are a lot of possibilities of how the design works. There will be a lot of confusion to decide which core is best suited for some specific input values. The steps to design transformer from the beginning to the end needs a lot of efforts and time, because there are a lot of equations to be solved. Hence, design solve all of the problem as users are only required to put the input values, and then the results with detailed component will be provided. For example, we just put the input and then the software will analyze which core type, which winding that are suitable for the transformer construction. For industry world, manufacturers will get their way much easier to manufacture transformer to fulfill one specific specification. Based on VI characteristic, which core that will be used, they can design best efficiency transformer to be produced and sold easier, and they will get more benefit. Okay, maybe that's it for the project description. There are a lot of improvements that I'm realized in. The program still has a lot of weaknesses, but it can be improved in the future. But for now, it is sufficient enough for having a good SMPS transformer design. That's it. Me, Jason. Thank you for the listening, and have a great day.